Okay, so we're going to continue where I left off on the last one, and in order to save time for uploading, I've wrote the entire notes down on these pages, and I'm going to walk through them, okay, and add verbal notes as we go through, okay? If you have a problem with any of this, just leave me a message, and I will try to answer it as soon as I can. So let's start off back with number 8. H of x equals x over x plus 5. Okay, so we were looking for vertical asymptotes. Okay, so you need to first find, factor anything if needed. So the top and the bottom here, that's factored, we don't need to factor anything. Okay, move that out the way. Okay, so there are possible vertical asymptotes when there's division by 0, like we said before. Okay, so things that aren't in the domain. So we set the denominator equal to 0, and you solve for that, and you get x equals negative 5. Now this is a possible vertical asymptote. Okay, and I'm going to use it later like this in the notes, VA. Okay, that's what I'm going to call vertical asymptotes. If the top and the bottom have a common factor, you would cancel that common factor. Now this one doesn't. Okay, but I'm going over an example here. If, for example, you had g of x is x over x times x plus 5, x would cancel, leaving you with 1 over x plus 5. Now, okay, so there would be no vertical asymptote at 0, just at x equals 5. Okay? X equals negative 5, therefore, is our vertical asymptote because nothing canceled. That was still in the denominator. Okay? Now, so this is our answer, x equals negative 5. Number 9. Oh, let me go over this. Note, if a top, is higher degree than the bottom, it would probably just be a hole, not an asymptote, if the factors canceled. Okay? For instance, if I had x minus 2, and I'll put a little box here, this is discontinued, times x plus 2 over x minus 2, okay? That will cancel, leaving you with just x plus 2. But here's the thing, 2 is not in the denominator. 2 is not in the domain because it would give you division by 0. So x can't equal 2. So what would happen is, since there's no denominator, after you cancel, then there's a hole at x equals 2, okay? Don't worry about that for this one. I didn't put a problem like that on the test. Okay, now number 9, x over x squared minus 4. First thing is you have to factor. Bottom is a difference of 2 squares, you factor the 2. No common factors, okay? So we're not going to have a hole or anything like that, but we may have vertical asymptotes. You set the denominator equal to 0 and you solve. Okay, x minus 2 equals 0, x plus 2 equals 0, and then you get x equals 2 and x equals negative 2. Again, no common factors, so nothing to cancel, meaning x equals 2 and x equals negative 2 are our vertical asymptotes. Okay? Okay, a lot to go through, so I'm going to keep going. Moving to number 10, 11, and 12, talking about horizontal asymptotes. Okay, so we're looking at the degree of the top and the degree of the denominator. Degree of numerator, degree of the denominator, okay? N here is the degree of the top. M is the degree of the denominator, okay? If N is less than M, top is less than bottom. Y equals 0 is your horizontal asymptote, or as I put it later, HA. Okay? That's it. That's all you have to look at there. If n is equal to m, okay, if the degrees are the same, then the asymptote is that y equals the leading coefficient of the top divided by the leading coefficient of the bottom. Okay? AN here, that's the leading coefficient of the numerator. And BM here is the leading coefficient of the denominator. Okay. If the top is bigger than the bottom, there is no horizontal asymptote. Okay. That's all you have to do for these 3 problems here. is just look at that information, see what it gives you. Number 10, 9x over 3x squared plus 1. The degree of the top is 1. Remember, it's the highest power of x, okay? The degree of the bottom is 2. N is less than m, so y equals 0 is your horizontal asymptote. That's all it was asking for, okay, for this problem. Now, you're going to need to use that later to graph and things like that, but one step at a time. Number 11, 4x squared over 2x squared plus 1. The degree of the top and the bottom are the same. So then what I do is I take the leading coefficients and I divide them. Okay, that's the coefficients, the numbers in front of the highest powers of x on the top and the bottom. That is where your horizontal asymptote is at. Okay, you divide the two, and that'll give you that. So y equals 2 is your horizontal asymptote for that one. All right, now number 12, 8x cubed over 2x squared plus 1. Degree of the top is 3. The degree of the bottom is 2. N is greater than m, top is greater than bottom, so no horizontal asymptotes. That's it. Okay? Now again, and I'm going to go over this later, you can cross over horizontal asymptotes with your graph. You cannot cross over vertical asymptotes. It's very important. Okay? It does not exist at the vertical asymptote. It can exist at a horizontal. Okay. So number 13 here was they actually asked us to graph the rational function. 2x over x minus 3. The first two things we need to do are to find the vertical asymptotes and the horizontal asymptotes. Now that may be enough if you have a multiple choice question. Okay, that may be enough for this one, it is. We don't need to go further. On the next problem, it's not. We have to go further. So for this one, I'll just go over this 2 steps, and then we'll move on to the next one. So, find the vertical asymptotes first. When does the denominator equal to 0? At 3. X equals 3. Top is factored, the bottom is factored all the way. No common factors, so that is a vertical asymptote. So at 3, we have this vertical asymptote here. Okay? Now, horizontal asymptotes. The degree of the top and the degree of the bottom are the same. So I divide the two leading coefficients, and I get y equals 2 is our horizontal asymptote. So that's what we have here. At the y equals 2, there's a horizontal line. Okay. Now my graph is rough. I understand that. The graph on the page is a little bit better. All right. There's only one graph that has those asymptotes. So you didn't need to go any further than this. Okay, and so for tests like the ACT and things like that, you can stop there because you know it has to be that one. All right. That being said, if you needed to actually finish graphing this, you would need to find the X and Y intercepts, like I've taught you. To find X-intercepts, it's set y equal to 0, solve for x. To find the Y-intercepts, set x equal to 0, solve for y. And then you would have to use a table of values around the X-intercepts and the vertical asymptotes. Okay? Table of values like we did, you pick x's and you find their y values and you plot those points, and that helps you kind of figure out where the graph goes. Now, the x's we pick here do matter. Like normally I remember I told you just around the origin, things like that. These you need to do it around the x-intercepts, like one on the left and one on the right. All right, and the same for the vertical asymptotes. That will tell you, is it above, is it below, things like that. Okay, which we need for number 14. Okay. Excuse me. So, here, graph f of x equals 2x over x squared minus 16. So again, we do our A and we do our B. We find the vertical asymptotes, we find the horizontal asymptotes. That may be enough. This one it's not. Okay? So, here, factor the bottom, difference of two squares, and we get x equals 4 and x equals negative 4. No common factors. So that means we have vertical asymptotes at x equals negative 4 and x equals 4. Okay, if you notice down here, I've drawn that. Negative 4, there's an asymptote. At 4, there's an asymptote. Okay, vertical. Looking over here, B, the horizontal asymptotes. Okay, this is vertical asymptotes. N equals 1 for the top, M equals 2 for the bottom. So N is less than M, top degree is less than the bottom, so the horizontal asymptote is at y equals 0. That's already drawn for us in the sense it's the axis, okay? That's the y equals 0 line. It's the x-axis. Okay, so it's kind of hard to draw on top. Just understand that's where it's at. If you look at my graph, I have some scratched out here. That's because I messed up and I can't find my whiteout right now. I'll explain. Okay, if you looked at your graphs on the answers, that wasn't enough. You needed to go further. So we said, okay, I'll find my x-intercepts. You said y equal to 0. Plug 0 in. Well, okay, doesn't matter what the bottom is as long as the top is 0. So I just looked at the top. 2x equals 0. Divide by 2. X equals 0. Okay, so when y is 0, x is 0. That's this point. Remember, x comma y? Okay, which is the origin. So it's both an x and a y intercept. Okay, it does both. All right, that being said, let's double check, find our y-intercept. Now here we only had one x-intercept. You may have more than one for different graphs. Depends on the graph. Okay. We've already gone over how to find those. Now find the y-intercept. Set x equals 0. You plug 0 in and you get 0. You get the same point. Okay. That's what we expected. Now, that's still not enough to graph this. You'll get these lines, but to draw these curves and understand this one here, that is not correct, okay? This is the correct curve. This right here. And I'll explain why in a second. Okay? So here, at -4, 0, and 4 for my x values, I need to pick a point on the left and a point on the right and determine, is it above or is it below that horizontal asymptote? Okay? Because for these vertical ones, it's always going to approach towards infinity or negative infinity. It's just which direction, on which side. So, here I picked, okay, so -5 and -3. That's around -4, right? So plug -5 in and I get a negative number. Okay, so that means it's below the x-axis at -5. So that means it's going down. Okay? So it goes in these areas here. Alright? So at -4 it's undefined. Then at -3 on the left side, I plug that in and end up with a positive number. So that means then I need to go up. Okay? Now then it crosses at x equals 0. Now here's the thing. Here I put -1 in, but I didn't really need to test -1. I just need to test somewhere between them. And that's enough for both of them, but I did test on both sides of each one, just to practice, okay? So, -1 is like right there, and 1 is right there. Okay. I plug -1 in, and I get a positive number. Well, that's the same. They should be. Okay, so that means it's still up here. Okay? Now, what you're looking for isn't necessarily positive or negative. That works if the horizontal asymptote's at 0. If it's at 2, you would need to look at, is it above 2 or below 2? That's what you're looking for. Here I'm looking for above 0 or below 0. Okay, if it's above, you go up. If it's below, you go down. All right, whatever your horizontal asymptote is at. That's your determining factor. So -1's that, at 0, it's 0, that's x-intercept. And then the right side, you plug in 1, and you get a negative number. Okay? So that means here I screwed up. I thought it was going to be positive, and I went up. Okay, but that's not it. Okay? It's down. Okay, down, because it's a negative number, it's below 0. That means it's going like this. Okay? Which should be confirmed if I picked, again, I put 3 and 5 in. Okay? I plugged in 3, I got a negative number. Yeah, it's still going down. It's going down to negative infinity here. Plug 5 in, well, I get a positive number. It goes up. Remember, I'm plugging these numbers into the original function, f of x. Okay? Now, slant asymptotes, or, and I'll put it here later, SA. Okay? Slant asymptotes only exist if n is greater than m, the degree of the top is greater than the degree of the bottom by 1 degree. Okay? It has to be like x cubed over x squared, or x to the 5th over x to the 4th. It has to be 1 bigger on top than the bottom. If that's not true, there is no slant asymptote. Okay, and if you notice on this test, I didn't ask you to graph one with that. Figured we could move on past that. You're going to use synthetic division to find the slant asymptote. It's the easiest way to do it, and it works really well. Okay, because the answer is in the answer to synthetic division. All right, so here, f of x equals x squared plus 4x minus 4 all over x minus 9. The degree of the top is 2, the degree of the bottom is 1. Yeah, there is a slant asymptote. Okay, so to do synthetic division, this is what I'm dividing by. So set it equal to 0, solve for that number, that's what goes in the front. Then I have the coefficients for x squared, x, and constant. Okay, it's a 1, remember that's 1 in the front if it's not there. There's a 4, and then there's a negative 4. So, bring down my first number. 9 times 1 is 9. Add the 2, 13. 9 times 13 is 117. Add the 2, okay? And remember, it's 1 less, so that means this is 1 less here. That's x, that's constant, that's my remainder. So I have x plus 13 plus this over what I was dividing by. Okay, but this part's not important. I don't need that. What I need is this. That tells me what my slant asymptote is. It's in the form of y equals mx plus b. It's a linear equation. We can graph that. We have the y-intercept at 13, and we have a slope of 1, okay? And so the answer to that one is A. I noticed I didn't put the answers for the other ones, I'm sorry. But you should be able to find them. Okay, so slant asymptotes, finding it is easy, okay? And then at that point, you would graph it like you would a normal one, but I didn't ask you to do that, so we're going to move on. That's 3.5. Now, the 3.7 section starts with variation. And the first thing I'm going to talk about here is direct versus, and I put indirect, and I apologize, inverse variation. So you either have y varies directly as x, or y varies inversely as x. Okay. All that means is if it's directly as something, that's in the numerator. If it's inversely as something, that's in the denominator. You also have this k value. That is a constant of variation. Okay, and you're going to be using that. You're going to have to solve for that later, but that needs to be in there. It's an important factor. Okay? So, number 16. C varies directly as f. All you had to do was actually write the function. C varies directly. Okay, so the as f is in the numerator. So C equals kf. Okay, that's it. All right, C varies directly as f. F varies directly, so f is in the numerator. Okay. Now, whatever's after this as is what goes there. So, for instance here, g varies, number 17, g varies directly as the square of t. So not just t, but the square of t. So that means that, g equals k, the constant of variation, times t squared. Okay? It's not just t, it's the square of t. Whatever's after that as right there, that gets it put with it. Okay? Gotta watch how you read these things. So if you just put t, you would have been wrong. But anyways, the answer for this one is B. Alright? Now, given values, you can determine what k is. Okay? So for instance, number 18, B varies directly as A. So right off the bat, we can write our formula here. B varies directly as A, so A is in the numerator. And when B is 35, A is 5, okay? So if I plug those two numbers into this formula, I can solve for k. So that was what we had there. All right. So then I divide both sides by 5 and I get k equals 7. Okay, so the actual, which is c, right? It was asking for the constant proportionality. By the way, proportionally or varies, you're going to use those interchangeably at the same time. You can use either one. Okay, so here b equals 7a would be your formula. Now you didn't need that for this one, but you will for the next ones and so on. Okay, number 19 is one where you have to actually find out what y is whenever another value is something else. Okay, so you're going to use that formula you just made like you did here. Y varies directly as z. Okay, so right off the bat, find, okay, you have y equals kz. And y equals 342 when z equals 19. That allows you to find k. Okay, this here allows you to find k. Alright? And so then you work it out, you divide both sides by 19, you get k is 18. Okay? It's k times 19, so you got to do division to move it over. Now, you use the k to find the new value. Okay, so our formula turns into, instead of y equals kz, we know k is 18. So y equals 18z. Okay, so plug in, it says find y when z is 16. We'll plug 16 in and find y. 18 times 16 is 288. And your answer is D. Okay? The word problems here look difficult, but it's really not. You just have to look for your key words. Okay, we're going to get to some in a second, but let's go over number 20. All right? Now, it goes here. Y varies directly as the cube of x. Remember, not just x, it's the cube of x. And y equals 4 when x is 28. This is what you're going to use to find k. So then it says find y when x is 7. That's your last step here. Okay? So A, we got to find k. Well, first you got to write the equation. Y varies directly as the cube of x, so x cubed is in the numerator. Okay? Use the given to find k. Okay? You have to have that to find k. Alright, so y is 4, x is 28. You plug in, yes, that's a big number. 4 equals k times 21,952. Divide both sides by that, and it does simplify just to, 1 over 5,488. I wouldn't use a calculator for this. I wouldn't plug it in, I wouldn't put the decimal, because that's going to throw you off, especially if you have to round. If you don't have to round the decimal, fine, whatever. But if you have to round it, it's going to throw your answers off. Since it's multiple choice, you'll still get close. Okay, so now we have k. So this is our formula here. Okay, that turns into that. Well, it says, okay, find y when x equals 7. Plug 7 in to x. So it's 7 cubed. Well, it's 343. Divide that by 5,488. That actually goes into that 16 times. Okay? So y equals 1 over 16 when x is 7. So your answer is B. At this point, you're just plugging in values and solving for what you don't have. Okay? 21, this is where it gets a little difficult. Okay? That's because it's a word problem. Yes, I know it's hard to read those things sometimes. There's a whole lot of words here. But I'll be honest with you, a lot of it's not really important. If you know a little bit, like for this one, it's about, this is 21, right? I'll read it out loud. If the resistance in an electrical circuit is held constant, the amount of current flowing through the circuit is directly proportional to the amount of voltage applied to the circuit. When 4 volts are applied to the circuit, 40 milliamperes of current flow through the circuit. Find the new current if the voltage is increased to 12 volts. They told you exactly the same stuff as in like number 20. Okay? They just spread it out into a bunch of words. You're still doing the same exact thing. So you got to find your keywords. What varies to what? Now here they use the word proportional, but the key word was directly too. Okay? So the amount of current is directly proportional to the amount of voltage. Okay? Didn't give us variables. I'm going to make some up on my own. The ones I'm using, they seem weird, but okay. So I equals current. That's actually from electrical circuitry. That's what they use for the variable for current. Capital I, and then they use a capital V for voltage. Okay? So here, I equals K times V, because the current is directly proportional, or varies directly, to the amount of voltage. Okay? I varies directly with V. Okay? And then it tells us when 4 volts are applied, so V equals 4, 40 milliamperes of current flow. So I equals 40. Now, the units don't really matter here, so don't worry too much about that. Just remember, if it's an I, it's milliamperes. If it's V, it's volts. Just use the same ones they're using in there for each thing. Okay? So, first of all, I is 40. V is 4, divided by 4, you get K equals 10. So the formula becomes I equals 10 times the voltage. Alright? Then it says, find the new current if the voltage is increased to 12 volts. So that means when V is 12, what is I? Well, I equals 10V, so I equals 10 times 12. So it's 120, and then the units are milliamperes. Okay? Because that's the units of the current. Okay. So that answer is number A. All right? Okay. Number 22. Now we're talking about inverse variation here. X varies inversely as V. Okay? X is 72 and V is 4. Find X when V is 32. Okay. X varies inversely as V. This goes in the denominator. Okay, because it's inversely inversely varying to it. So X equals, the K is still on top. K is always in the top there, over V. Okay, and so when X is 72, V is 4. Multiply both sides by 4, and you'll get, right here, K is 288. So our formula becomes X equals 288 over V. Okay, because K is 288. Now it says find X when V is 32. Plug 32 into V. X equals 288 over 32. So X equals 9. Our answer is B. Okay, same as directly. It's just it's in a different position in the fraction. That's it. Okay. 23 was another word problem. But again, we're just looking for the key words here. All right? I'm not going to read it out loud. You can read. But the key words were here. It says volume is inversely proportional, or varies inversely, to pressure. So I said, okay, capital V is volume, capital P is pressure. Volume varies inversely to pressure, so that's K over P. Okay? And it tells me when V is 160, P is 14. Okay? And it says find P when V is 32. Okay? Plug in my values to find K, because this is my given. Alright? 160 is V, 14 is P. Multiply both sides by 14, K is 2240. Okay. So my formula becomes V equals 2240 over P. Okay, well it says find P when V is 32. So plug 32 into V, and I got to solve for P. Okay, now here's the thing, it's just in a different position. You just move the stuff around like you do in normal algebra. So I'd multiply by P, okay, cancel that. So I get 32P equals 2240, and then I divide by 32, okay? And so then I get P equals 70, and the units for that were pounds per square inch, okay, which is letter C. Okay, you're following the same steps. It's just here you were given this side instead of that one, which is okay. You just solve for it like normal. All right. Again, 24, another word problem. I varies inversely as the square of D. Okay. I varies inversely as the square of d. So it means d is squared on the bottom because it's inverse. Okay, we still got to find k. What's my given? When d is 56 feet, I is 2.7 feet candles. That's a unit of intensity. Okay, so plug in my values, solve for k. K is 8,467.2. All right. Sorry. All right. So I equals 8,467.2 over d squared. Okay, well, what is I when d is 70? Plug it in, divide, you get your answer. All right, that's it. That's all you got to do. Now, 25 and 26, those, you just have both parts. Just remember, when it's directly, it goes in the numerator. When it's inversely, it goes in the denominator, the bottom, okay? So, w varies directly as x, and inversely as the square of y. X goes in the top, square of y goes in the bottom. That's all you needed to do. You didn't have to solve anything for that one. You just had to put it in the right positions. All right? Directly means it goes in the numerator. Inversely goes in the denominator. Okay? So here, number 26. H varies directly as f and inversely as g. So it's the first thing we want to do. H equals k times f is directly, so it's in the top. G is inversely, so it's in the bottom. Okay? And h equals 5 when f equals 63 and g equals 45. This is what I'm using to find k. You plug it in and you solve for k. Okay? 5 is h equals k times 63 divided by g, which is 45. I multiply both sides by 45. I got this, and I divide by 63, and then that simplifies down to 25 over 7. Okay? That's my constant of proportionality. That's all you were asked for on that one. Okay? On the next one, you're going to have to actually use that constant because it is also, again, another word problem. Look for the key words: directly proportional, inversely proportional, or varies, whatever it says. So volume, I said is V, is directly varies directly as temperature, which is T, and inversely as pressure, which is P. So V equals K, T goes in the top, P goes in the bottom. All right? Whatever's right here, again, remember that goes in the front of the equal sign. All right? So it varies with other stuff. All right. So it says here, V equals 144 when T equals 240 and P equals 25. Again, as long as you keep your units the same as what they give, it'll work out fine. It'll work out fine. Okay? So it's asking, what is V when T equals 500 and P equals 10? That'd be degrees. Pounds per square inch. All right? Well, I got to use that to find K first. So plug it in. V is 144 when T is 240 and P is 25. So multiply both sides by 25. Okay, and we got 3,600, and then divide by 240, and we get K equals 15, okay? Which leads us to V equals K is 15 times T over P. And then we're given, okay, what is V? We're looking for that. When T is 500 and P is 10. Plug it in. T is 500, P is 10. Work it out. 750. Now remember, volume was in inches cubed, so volume still in inches cubed. Okay, you're going to keep the same thing. Why these things are important, why I'm even teaching, is because these are where your formulas are found for physics, for chemistry, for all these kinds of things. We learn as things vary directly or indirectly or inversely. Okay, it's all related through that. Okay, that's how they found pi. It's because they used the circumference of a circle. They kept measuring it for different distances of r. Okay, and so they did a little tiny one. Okay, and so they had given values, and they found that, or a guy found it, I forget his name off the top of my head. It has a constant of proportionality, and in that one, for k, is pi. Okay, so we get, and this actually varies to the diameter. Okay, and so we have circumference is pi times the diameter. That's the constant of proportionality. Okay, that's where pi came from. The guy used this method. All right, he had given values, he plugged it in. You could do that too if you really wanted to. Joint variation just means they're multiplied together. That's the simplest way to put it. Okay, z varies jointly as x and y. That means you multiply x and y together. Okay, so z equals kxy. Find z when x is 35, y is 14, and k is 5. It gave you the constant. You didn't even need to work it out. Right? You plug in the numbers. Okay, and you multiply it out. Z is 2,450. That's letter A. All right. 29. F varies jointly as q squared and h. F is 144 when q is 4 and h is 3. Find h. Remember, watch what it's looking for. You're looking for h when f is 60 and q is 2. First thing is, write your formula. Varies jointly as q squared and h. You're going to multiply them together, and then you have your constant in the front. All right. You plug in these values to find k. 144 equals k times 16 times 4 squared, which is 16, times 3. And when you work that out, you divide that, you get k is 3. Okay, so you're going to plug k in. This is my formula now. I'm looking for h now. When f is 60 and q is 2, I plug in my values. 60 equals 3 times 2 squared times h. 60 equals 12h, divide by 12, h equals 5. Okay, you plug it in, plug in what you know to solve for what you don't. All right, last one, number 30. All right, power is jointly proportional, or varies jointly, to the square of current and resistance. Okay, that's what you're getting from that. So put P is power, I is current, like I used earlier, and R is resistance. Jointly proportional to the square of current, I squared, and resistance, R. Those are multiplied together. So P equals K, I squared, R. Okay, and it tells us power is 8, when current is 2, resistance is 2. Okay, what is power when I is 4 and R is 9? All right, now plug in the first parts to find K. 8 equals K times 2 squared times 2. 8K equals 8. You divide by 8, you get K is 1. And so that means that this becomes just P equals I squared R. That is actually a formula you would learn in physics for electrical circuitry. Okay, that's the formula. That's how nature works. So P equals I squared R. Well, okay, well, what's P when I is 4 and R is 9? Plug it in. 4 squared times 9, 16 times 9, 144, and power is in watts. Okay, D. Answer is D for that one. I know I went through this quickly. I know this can be difficult. Take the time, pause this video as you need, look through it. Do you have any questions about what I did? Let me know, answer it. Again, you can reach me on there. I'm going to try to set up some kind of a time and a classroom that I can set up on Zoom or something like that, so that y'all can ask me questions one-on-one, because this, I'm already at 39 minutes now. These are long videos. Okay?